All right. Hello, everyone, and welcome. We're going to get started in just a moment. We're going to give folks a couple minutes or just about a minute or so to get settled, but we're super glad you're here. All right, I can see folks are still joining, and we'll get everyone situated as they come on in. But I would like to say hello and welcome to our December Night Sky Explorer program with Astro Bob King. It's going to be great. I hope you're sitting down because you're gonna be blown off your feet with this one. This webinar is brought to you by the Voyageurs Conservancy, the official nonprofit partner of Voyageurs National Park. Voyageurs Conservancy helps promote and protect the park by funding conservation and education programs. Our Night Sky Explorer series brings together night sky appreciation and astronomy skills for everyone. Even you, even your best friend, even your neighbor down the street, everyone. If you are interested in learning more about dark sky preservation at Voyageurs National Park and viewing previous Astro Bob webinars, please visit voyageurs.org/darkskies. All right, Bob King fell in love with the night sky as a child and is a passionate educator. He served as photographer and photo editor at the Duluth News Tribune for 39 years and taught at the UMD Planetarium for many years. Bob has written several stellar books, including The Urban Legends of Space, which explores astronomical science versus pseudoscience. So again, thank you so much for joining us this evening. And without further ado, here is Astro Bob King.
Hey, Laura. Laura, thanks very much. Great to be here again tonight before the giant storm that's coming into the upper Midwest, actually across a good part of the country. Thanks for being with us this evening, all of the viewers. And we have cloudy skies here, but it will clear up eventually and we'll see some cool things. I'm going to talk about some of those things that are visible to the naked eye, a little bit with binoculars in the coming minutes, and also discuss twinkling stars, something we've all seen and enjoyed, I think. So feel free during the presentation, you can go into click on the chat button there at the bottom of the screen and put in a question if you'd like, and I'd be happy to answer it. Laura, if you would give me kind of a heads up when one of those questions appears, that would be wonderful. So with that, I'll share my screen. We will head on over to our program tonight and get ready to get your eyes all sparkled because we have lots of sparkly stars to begin with. I've titled this Twinkling Stars and Your Celestial Highlights. So the main star we'll talk about, of course, is Sirius, which is the brightest and the most prominent twinkling star. But we'll also look at what you can see right now on through the end of the year and a little bit at the beginning of 2022, the year that lies in wait for us all. We've talked about this, and no doubt you have seen this wonderful lineup of planets in the evening sky. We have Jupiter at top, Saturn down the middle, and lowest in the sky, the planet Venus. They are all neatly lined up in the southwestern sky at dusk this time of year. I've put it there for December 15th, but you can go out tomorrow night after. Best time to view these planets is between 45 minutes or so and an hour after sunset. Don't wait too much after an hour because Venus is dropping lower and lower into the dusky sky. Here's Venus. Really stands out by itself. It is the brightest of all the planets. The reason being it's covered in clouds and it's relatively close to the sun, so it reflects a lot of sunlight, makes it especially brilliant. You can find Venus at the bottom of that line, but in the coming 2 weeks, it's going to be dropping lower and lower and become more difficult to see. So see it now because it'll be out of the evening sky by the very beginning of the new year in early January. This is a view in twilight, once again, on the final day of the year before you hit your New Year's Eve party. You can look to the southwest, you'll see Jupiter again. a fainter Saturn. Saturn is a smaller planet. It's also farther away, so it's dimmer. Venus, notice from before, it's actually gotten a little bit lower. It's been dropping down towards the horizon. And as if sensing Venus, its ultimate disappearance, as if sensing that Mercury has sort of moved into the position of the line, replacing Venus, as it were. Mercury will be quite low. It should be visible, though, in a pair of binoculars starting at the end of the year and then in the coming 2 weeks after that, first 2 weeks of January. On the 4th of January, the moon returns to the sky. It will lie right near Saturn. It'll be in conjunction with the planet Saturn, a beautiful thin crescent. But look around the sky and you will see that by the 4th, Venus has left the picture. It's gone. Where the heck is this planet gone? Well, it's switching from being an evening star, moving in front of the sun where we won't see it because of the solar glare, and then swinging to the other side of the sun, to the, to the west of the sun, when it will rise at dawn. So it's moving from an evening star to a dawn or morning star. Before it does that, get your big binoculars out and point them at Venus. Focus as sharply as you can, because you're in for a delightful surprise for the next week or so while Venus is still fairly easily visible. You will need a good view to the southwest to see the planet. Point your binoculars at Venus. You'll need about somewhere between 7 and 10 power or higher. And you will see that it's actually a crescent. It looks just like a mini moon, just this tiny little white moon crescent, fingernail crescent. And it goes through phases. I know we've touched on this before, but right now, Venus is in its most beautiful phase. It's also relatively close to the Earth, so it's larger than normal, which means all you need are binoculars to get a sense of or to discern that tiny fingernail crescent. Why does Venus have phases? Well, like Mercury, and I've drawn in Mercury's orbit for you too, and here's Venus's orbit on the outside of Mercury. Both planets orbit inward from the Earth, okay? They are inner planets from the Earth, so we look towards the sun's direction to see them. When Venus is directly lined up on the opposite side of the sun, it looks like a tiny, tiny full moon, because the sun fully lights its front face, and we see it in the telescope as a little teeny dot. As it begins its orbit around to the left or east, as we see it here in the northern hemisphere, it moves away east of the sun and appears in the evening sky. So the sun sets, Venus is to the east, so it sets after the sun. This is the Venus evening star phase. When it's halfway around when it's a quarter way, around its orbit, from our perspective on the Earth, half of Venus is lit. So it looks just like a half moon. Now Venus is approaching its conjunction with the sun, where it will line up between us and the sun. And at that point, we only see the edge lit. We see a crescent Venus. Then it passes directly between us and the sun, when it'll be lost in that solar glare. So that occurs beginning in January. And after that, it continues in its orbit. It never stops, right? The planets just keep orbiting in their circles. Venus moves to the right of the sun from our perspective. And that means it's now west of the sun. So it appears before the sun in the dawn sky. So later in January, after this alignment, Venus will switch over into the dawn sky and then go through the whole cycle again. It spends months in the dawn sky. It's in conjunction once again on the opposite side of the sun when we can't see it, and then it swings back into the evening sky. It's a pretty cool thing. And Mercury does the same. It's just that it's closer to the sun. Look at its orbit. It's closer to the sun, so it doesn't get quite as far from the sun as Venus does, which means Mercury is really only visible in fairly bright twilight because it makes a smaller loop. I checked out to see when Venus will return to the morning sky, and that will be around January the 20th. You can look about 45 minutes before the sun is up. It will be a crescent, just like it is now, but you can probably figure this out. It'll be lit by the sun on the other side. So instead of a crescent on the right, it'll have a crescent on the left. It's really cool. You get a sense of its orbital motion and how it switches from one side to the other as it swings between the Earth and the sun. Also coming into view, much fainter, is the planet Mars. It returns this year and it will be very bright come this winter, but right now it's still faint, distant from the Earth and in the morning sky. We also have a beautiful, big, bright full moon coming up, appropriately named for December, the full cold moon. And I do think it's going to be cold this time around after these storms make it through. That occurs on Saturday evening, December the 18th. The full moon rises directly opposite the sun. We have the sun here, the Earth, and the moon. When the sun goes down, the full moon comes up. They're 180 degrees apart. So that's why we always look for the full moon opposite the sun right around the time that the sun sets. When the moon first comes up, we've all noticed that it's quite orange or kind of pinkish orange in color. It could be really a beautiful color, very intense. As the moon climbs higher, however, we see it through less and less atmosphere, and its color changes from orange to white. So let me explain. When we see the moon near the horizon, we are looking through the bottommost layer of the atmosphere where the air is thickest, densest. When our gaze is pointed upward, we look through much less atmosphere. So through the bottom of the atmosphere, the air molecules themselves actually scatter away the blue, the purple, and the green colors in moonlight. Remember, the moon reflects the sun, and white light, sunlight, is basically, it's made of all colors of the rainbow. The air, the thick air, selectively removes all the cooler colors, and that leaves just the warmer colors. So the moon appears quite orange near the horizon. As it scales the sky, however, we see it through less atmosphere. Here's a diagram to kind of help you see it. There you are down there on the Earth. You're looking at the moon through a lot of atmosphere, and so it looks orange. And it's really just the air molecules themselves that are doing this. By the way, if my voice blurs a little bit, my internet is a bit slow here. I apologize. When you look through, when the moon is way up high, as it will be, the December moon, by the way, is in the same place in the sky as the sun was back in June. It takes virtually the same path. So the moon's going to get really, really high up, and it'll just completely light up the landscape. So we'll be looking at it through much less atmosphere, and the moon will look pure white. Another really cool thing happens when the moon rises and we look through the air to see it. That air is so thick, it acts like a lens or a prism, and it bends the moon. It causes the moon to look squashed. And how it happens is that the air at the bottom of the, let's look at a picture so you can see. Look at that crazy rising moon. It just looks like a pancake or a roll or something like that. But what happens is the air where the bottom of the moon is, we're looking through thicker air there because it's closer to the horizon. The air at the top of the moon is a little bit thinner. So the atmosphere where it's thicker is a stronger prism, and it bends the bottom light of the moon upward into the top. It raises the bottom of the moon into the top half. And when it does that, it gives the moon a squished appearance. And that's strictly caused by the atmosphere, this bending called refraction that's caused by that very dense air. So this bottom half of the moon is being pushed up into the top half just because the atmosphere is literally lifting it up and pushing it into it. When the moon rises higher, we're looking through much less air, as you saw in the previous diagram. And that means the moon just sort of rounds out nice and clear. Refraction, that bending power, is very, very much less when you look at a steep angle at the moon, and very great when you're looking along the horizon. The other thing about the moon, and especially full moons and around the time of the full moon, is if there are clouds in the sky, you might think, oh, I'm not going to go out tonight and look at the moon. But I encourage you to go out when there are clouds and the moon is near full, as it will be this weekend, because the bright moon can sometimes create beautiful halos in the sky. You know, those rings of light, those are caused by ice crystals refracting, bending once again the moonlight itself, and turning it into a circle around the moon called a halo. Other times, certain kinds of clouds can pass in front of the moon, and these clouds have extremely tiny water droplets in them, and they diffract the light. They cause light to sort of interfere. The light waves mingle and interfere with one another, and they create these color fringes around the moon called a corona. And this is a real photograph, and it was exactly this vivid to my eye. I could not believe the colors. And you could see this anytime around the full moon phase when the moon is bright. So watch for it. Especially if a front is coming through on a clear night, you'll often get these kinds of clouds that produce coronas. And now what you've been waiting for, twinkling, Sirius. We're gonna focus on Sirius because it is the best twinkler in the sky. It's the brightest star in the entire heavens, no matter what hemisphere you happen to be in. One of the reasons for that is Sirius is close to us compared to many, many stars. It's only about 8.5 light years from the Earth. It's also twice as massive and brighter than the sun. So it really has some power out there when you look at it. Sirius is visible right around 10 o'clock in the evening. Well, actually a little earlier. You can start as soon as 9:30. 10 o'clock, you'll see it rising in the southeastern sky below the belt of Orion. It is the only brilliant star in that part of the sky. Sirius twinkles madly, first because it's bright, second because from at least the northern states, Sirius never gets very high above the horizon, so it's more affected by the atmosphere. As a matter of fact, when you do identify Sirius, go out a little earlier, as early as you can, so that you can see it closer to the horizon. Say 9 o'clock, go out and look for Sirius. Then you'll see it through very thick air, like we've been talking about with the moon. And that thick air means that the path that the light takes really gets distorted. It gets all twisted up by the atmosphere compared to when Sirius is up high. And that twisting and shifting is what causes it to twinkle. We can't see these things, but within the air, even on a calm night, you might think the air is all the same temperature. Even on a calm night, there's these little cells or eddies of air, each one of a slightly different temperature. As Sirius's light penetrates through these eddies, each one of those little cells refracts like a lens or prism and shifts the light of Sirius a little this way, a little that way, a little this way. In effect, it's moving the star around the sky as Sirius's light is trying to reach your eye. Count all these eddies, and it bounces and moves the star around. And this is, in fact, what you're seeing when you see this star twinkle. You're seeing all of the cells of the atmosphere moving rapidly between you and Sirius, causing this sometimes almost violent, like firecracker-like flashes. It depends upon how stable the air layer is. And so you get twinkling. It doesn't just happen to Sirius naturally, but all the bright stars twinkle, obviously to the eye, because they're bright. And you can discern, you can see that twinkling. Fainter stars will twinkle too, but it's not nearly as obvious just because they're faint. But everything twinkles. If you want to get rid of all twinkling, go to the moon. There's no atmosphere to mess with the stars. Every star from the moon is perfectly sharp and perfectly steady. Another most interesting thing happens with Sirius and bright stars. Not only does it twinkle, you look at it casually and it looks just like a white twinkling star, but on some nights when it's twinkling, what I say violently, it's a strong term, but it describes it for me. On some nights when it's really twinkling, study it, focus your eye on the star, and you'll notice that not only is it white, but it's twinkling red, sometimes green, it'll flash yellow, sometimes it disappears completely as one of those air cells redirects the light away from your eye. It goes through all of these different colors of the spectrum. And the reason for that is, once again, the atmosphere acting like a prism, spreading the light of Sirius into a tiny, tiny rainbow. It does it all the time. Here's a telescope. Here's what Saturn should look like. But when it's low to the horizon, the atmosphere bends the light and spreads the light of Saturn into individual colors, exactly like you saw in that prism. Let's go back to the prism. You see we have white light on the left, and it goes through the prism and it comes out in multiple colors, all the colors of the rainbow. Same thing happens with Saturn. Saturn comes, instead of being a nice white object, it looks color. Part of it is red and part of it is blue and green. That's when it's close to the horizon. The same thing will happen with the moon. You'll see a greenish edge to the moon if you use binoculars and watch it rise, and a red lower edge. It's being spread like you saw in the previous diagram. And here's a picture of Mercury really close to the horizon, and it looks just like a rainbow. So let's get back to Sirius with that in mind. Here's Sirius. All right, big bright star, powerful star, travels 25, let's see, 6 trillion miles per light year, 50 trillion miles this star travels. Then it encounters this thin onion shell of an atmosphere. And all of a sudden it's shaking, moving, and it's doing it in every color of the rainbow. Because once again, the atmosphere spreads the light like a prism into each color. And as you look at Sirius, everything is in motion. So you'll see red, green, blue. I took my camera one time and photographed Sirius. I defocused it. These are individual images of the star. I defocused it and tried to capture all the colors you see when it twinkles. And these are just some. Look at these amazing colors. We have blue, green, and pink, and blue, and orange, and yellow, all kinds of different hues. And these are real images. I saw this color in the camera, and you can see it with your eye on nights when the star is really twinkling wildly. It is the best star. And if you have any difficulty seeing this with the naked eye, take your binoculars and aim it at Sirius. It will brighten the star more and enhance the colors. Well, I wanted to be sure to remind you, not that we need to be reminded necessarily, because this always happens around Christmas. We are approaching the winter solstice, which is the start of winter, the very first day of winter. That occurs on December the 21st, which is next Tuesday. And at 9:58 a.m. Central Time, the sun will be at its lowest point in the sky. We certainly remember in summer how high the sun was around the summer solstice. And again, that's where the moon is now, because the moon is opposite the sun. And since the sun is super low, the moon is super high. So we have the summer solstice, the winter solstice. During the summer solstice, the Earth is tipped, the orientation of Earth's northern hemisphere is towards the sun, sort of leaning towards the sun, so it raises its altitude in the sky. 6 months later, the northern hemisphere is tipped away from the sun, so the sun appears to drop or become lower in the sky. So it's only up for a few hours. Shortest days of the year, longest nights, cold temperatures. Here's just a little diagram showing you a little more in detail how each hemisphere works right now. If you live in South America, it's going to be summer in just a week or so. And here's the path the sun takes, just to demonstrate to you how high it is in the summer. In the spring and fall, it's kind of an in-between time. And in winter, the sun is very low with very few hours of daylight. We just had, and it's actually still in the works right now, a meteor shower. And maybe some of you got to see the Geminid meteor shower. I hope it was clear and that you maybe stayed up late to see it, because it was a really good shower this year, even with some moonlight. It was mostly cloudy here where I live, but it cleared for an hour, right at 5 a.m. And I got outside and I saw 15 of these meteors that appeared to emanate. They shot out of the constellation of Gemini, hence the name Geminids. And these meteors come from a little asteroid called Phaethon. Here's a photograph of one I took with my camera. You can see the clouds passing through, and it looks just like a needle right there. It's a fragment of the asteroid. The Earth strikes it as we're moving in our orbit, and it burns up and forms a bright streak of light in the sky. Sometimes we call it a shooting star. The Geminids are still active. If it's clear over the next few nights, you might see a Geminid here or there, but of course, with the full moon, we're not going to see many meteors. The moon drowns out so many meteors. However, you will have an opportunity, or we will have an opportunity very soon to see another meteor shower, which is a pretty good one, called the quadrantids. It's named after a sextant-like instrument called a quadrant that was used to plot the positions of the stars. The constellation is obsolete now, but it once existed right here between Boötes and right down below the Dipper's Handle and across from Draco. And they're called the quadrantids because there used to be a very faint constellation there, never made the big hit list, and it's disappeared now. But this, we still remember the constellation through the name of the shower, the quadrantid meteor shower. Good night, the dark sky, you might see approximately 50 meteors per hour from this shower, so it's well worth watching. Unfortunately, you can't go out at 10 o'clock to see it. The best time to view is from 3 a.m. until sunrise. Ouch, right? But still, I wanted to let you know about it. It peaks on the morning of January the 3rd, and it occurs when the Earth, here's its orbit, the blue ring you see there, and here's the Earth. Here's the orbit of the asteroid 2003 EH1. And this asteroid has shed rocks and dust. And the rocks and dust are now orbiting in that oval. Every early January, every year, the Earth passes through that band of material. And when it does, it strikes the atmosphere at high speed and burns up, and we see a meteor. The very same effect can be seen, except snowflakes don't burn up, but the same effect can be seen when you drive your car at night into a falling snowstorm. You will see that the snowflakes appear to focus ahead of you in that single direction. The same thing happens with a meteor shower. As Earth plows into the material, the individual little bits of debris appear to stream from a point in the sky, and that point is in quadrants, and it's called the radiant. So every meteor shower has a radiant because the Earth is headed in that direction, just like your car in a snowstorm. Finally, I wanted to mention the Northern Lights. We don't have anything happening right now. We had a couple of great displays in the year 2021, and I'm sure we'll have even more displays in the coming year because the sun is becoming more and more active. It has a cycle, an 11-year cycle where it starts low in activity with very few solar flares, which are basically the cause of the Northern Lights. It amps up and peaks, and then it drops back down. The full cycle takes 11 years. We're on the upward part of that curve, which means more storms, greater potential for Northern Lights in the year 2022. Next chance of possible aurora is right after Christmas on December 27th and 28th. And I just checked the sun today. There's a whole bunch of new sunspots that have come out all in a row on the sun. And if those sunspots become active and produce storms, it's possible we may see Northern Lights sooner than December 28th or 27, 28. So we always hope that that will happen. And I will certainly alert you on my blog when it does. And with that, that's the end of my presentation. And if you have any questions or comments you'd like to make, feel free to do that right now.
Bob, it looks like we've got a question. Did you see Comet Leonard? This person tried and doesn't think that they saw it.
Oh, when did they try? Can we ask?
Yeah.
And while you're, or maybe you can ask in the chat, yeah. But yes, I did see Comet Leonard. I saw it several times back in October, November. The last time I saw it was during the almost total lunar eclipse. The sky got dark enough, and I made sure I spent a few minutes looking at the comet through my telescope, because after that I took a very long trip and I missed the best part of Comet Leonard. And now it is no longer in the morning sky. It used to be visible before dawn. You could see it in a pair of binoculars just within the past week. However, it's moving closer to the sun, and it's out of the dawn sky, and it's visible at dusk, but it's very, very low. And I'm waiting for the next clear night to see how easy or not it is to see. And then I will make a chart or a map to help other people find it. If it's relatively easy, there's still opportunities to see it, but it will be quite low in the southwestern sky. So you'll need a really good spot with a clear horizon, right pretty much down to the horizon. If you live in the southern hemisphere, this is the best time for Leonard, because from that perspective, it's moving up, up, up higher in the sky. The irony is I was just in the southern hemisphere. I missed Leonard's best view in the northern hemisphere. Now that I'm back in the northern hemisphere, it's really going to look good in the southern hemisphere. So be it. That's how it happens sometimes. Did you find out when the person tried?
Yes, it was last week.
Last week. And if they had you needed a good map to find it last week. It wasn't a comet like Comet Neowise last year, where you could go out under a dark sky and there it was. For this, you had to really know just where to look. And it was not visible with the naked eye. You would definitely have needed a pair of binoculars to see it. And with binoculars, it would have appeared as a fuzzy blob with a short, stubby, faint tail sticking right up out of it. So I'm sorry, it sounds like you maybe missed the comet then, but I hope we still have an opportunity to see it in the evening sky. And I will publish a chart on finding that for you.
Awesome. Thanks for that kind of rundown, Bob. I know we're a little over time. I have a quick question, if
Yeah,
that's
go ahead.
okay. So I'm curious, as we kind of transition, as we see constellations, we have summer constellations in the northern hemisphere and winter ones, right as they're kind of hugging the horizon in our skyline, do they twinkle a lot more since we have to look through so much atmosphere? Is that like any star's twinkliest when it's about to vacation to the other hemisphere?
Yeah, it's when all the stars that we see in the northern hemisphere, they just repeat. They will cycle back around every single year, so they don't go down to the southern hemisphere and go on vacation. It's a good idea though. But when any bright star near the horizon will twinkle most, because again, we're seeing it through more air, which means more of those little individual cells and pockets of all those different temperatures. And so it's really going to shift and shimmy the light around. So Sirius is really twinkly, or Betelgeuse or Rigel, any bright star, when it's within, I'll say, one fist. If you reach your fist out and put the horizon on the bottom, if it's within a fist of the horizon, you're really going to see twinkling. The higher it gets, the less atmosphere you look through, the less twinkling. Applies to any bright star. Sirius just stands out because it's the brightest, and so it's easiest to see it twinkle. Does that make sense, Laura?
That makes great sense. So it sounds like all bright stars have their moment to twinkle, no matter kind of where we are in relation to them.
They do, yeah. All bright stars. And if you're in the southern hemisphere, when the Southern Cross is low on the horizon, you'll see a lot of twinkling. Alpha Centauri and all those southern stars too. They all do the same because we all share that same atmosphere. Some places though, the air is very, how should I say, the temperature is very smooth. There's no dramatic transitions in there. And stars on some nights and in some places barely twinkle. When you look up and you see a star barely twinkle, chances are the atmosphere is fairly calm. And that usually means sharp images through your telescope. When there's a lot of twinkling, a telescope will show all this movement and blurriness. But when it's quiet, and the stars are steady. The images are usually quite beautiful in a telescope. Remember, you're magnifying the telescope, so you magnify twinkling too.
Huh, that's
Yeah, amateur astronomers, I always keep an eye on stars to see how much they twinkle before I set my telescope up. And if a low star shines steadily, like if Sirius looks really steady, I know that the images will be sharp when I magnify them. It's a good, kind of a good way to check out the sky, to kind of get a hint of what you're going to see by following twinkling. And astronomers do not like twinkling, professional astronomers, and they've devised special mirrors that flex so that they can remove the twinkling from the star. They actually bend the mirror and they can cancel twinkling and produce steady images, sort of like the way when you hold an internally stabilized camera lens. If you've ever held a DSLR camera and you press the button, the image will be steady. So there's ways to counteract twinkling so astronomers can get sharp images of the stars, because they don't like it at all. We think it's beautiful. It's aesthetically pleasing.
Oh my gosh, that's every time, Bob. Every time you always share stuff that blows my mind. I love it.
Yeah, this is great. The twinkling is a wonderful topic, and I encourage anyone to go out and just look it up online too. It's also technically has another technical name. It's called, and it's a lovely term, it's called scintillation. So
there was a clap of thunder just as you said that to add drama in the Twin Cities. So
so it begins.
It begins. So with that, I want to thank Bob, and I want to thank everyone who joined us tonight for another fantastic Night Sky Explorer webinar. Be on the lookout for next month's program and visit voyagers.org/dark skies to learn more about our night skies. And before we log off and everybody stays safe and gets ready for whatever storm they might be facing, Bob, do you have anything else for us before we?
Nope, I think it's good. I want to wish everyone a great holiday season, a wonderful new year, and we will be back together again in January with some news about what's coming in 2022.
Oh my gosh.
Thank you for having me.
Thanks, Bob, and everyone have a great night. Be safe.